Welcome to qnawire.
Here we're going to apply for part A Newton's second law to the airship, and then we Archimedes' principle for the buoyancy force. Essentially, the fluid that exerts this force is the air. So we can first say that then we can draw this free body diagram. Going straight up would be the buoyancy force. This would be equal to the density of air multiplied by V times G. Going straight down would be the total mass times G. And here we can say that the lift corresponds to a mass. We can say mass of lift. This would be equaling 90 times 10 to the third newtons multiplied by, or rather divided by 9.80 meters per second squared. This is giving us 9.184 times 10 to the third units, of course, kilograms for mass. So the mass total would be equaling, we can say 9,184 kilograms plus the mass of the gas. And so we can set up Newton's second law. The sum of forces in the y direction would be equal to the mass times the acceleration in the y direction. We know that this is equaling 0. And so therefore we have that the buoyancy force, or we can write it, the density of air multiplied by V times G would be equal to that total mass, 9,184 kilograms, plus the mass of the gas times G. Of course, G's are going to cancel out, and so we can write the mass of the gas in terms of V. So we can say the mass of the gas would be equaling the density of the gas multiplied by V. And so we can then say that the density of the air multiplied by V would be equaling 9,184 kilograms plus the density of the gas multiplied by V after canceling the G's out, essentially. So for the answer for part A, for the volume, this would be equaling 9,184 kilograms, and then divided by the mass of the air, 1.20 kilograms per cubic meter, minus the mass of the gas, 0.0899 kilograms per cubic meter. And we find the answer for part A being the volume equaling 8.27 times 10 to the third cubic meters. This would be our final answer for part A. For part B, then, we can say that we're going to let m sub lift be the mass that could be lifted. So from part A, we find that mass sub lift is going to be equaling the density of air minus the density of the gas multiplied by the total volume. And so we can solve. This would be equaling 1.20 kilograms per cubic meter minus 0.166 kilograms per cubic meter, and then multiplied by V, which we know to be 8.27 times 10 to the third cubic meters, and we have a mass of approximately 8,550 kilograms. And so the lift force would be the mass of the lift times G. This would be equal to 8,550 kilograms multiplied by 9.80 meters per second squared. And we find that this is equaling 83, we can say 8.38 times 10 to the fourth newtons. This would be our final answer for part B. That is the solution. Thank you for watching.